Hello, good morning. Today we are going to talk about the introduction to Big Data and Hadoop. Before going into the Big Data, I would like to mention why data. Why data is very important. Today's world is a data-driven world. Data helps us to make better decisions. It helps us to solve problems, and it helps us to see the performance, and it can also help to improve the process. And it helps us to understand the market and the customer. Data helps us to define the descriptive problem, that is what happened, what is my reporting on the accurate sales, and even why did it happen, why my sales is low, like which is called the diagnostic report. It also helps to find out the predictive analysis, that what will happen, what will be my forecasting of the future sales, and also my prescriptive analysis. What should happen? Example, send a mail to the customer who look like they are about to lapse. So data is helpful in all our day-to-day life and helps the business to improvise on the process and as well as on the revenue. So why big data? Now, the data is helpful as we have already seen. Now that we have a rich data set now. For example, if you take every 60 seconds, we have around 98,000 tweets. And every 60 seconds that we have around 695,000 status updates. And every minute that we have nearly 270 new mobile web users are creating nearly yottabytes of data. If you take in early days that we were maximum used to have only till the gigabytes of data. Now we have beyond gigabytes, terabytes, petabytes, exabytes, petabytes, and then yottabytes of data. So the data is very huge, which this tremendous amount of data can help us to give new insights about various things. So that's why it's a big data. So big data is a term that describes a large volume of data, both unstructured and structured, and which can help in our day-to-day basis. So big data is data whose scale, diversity, and complexity require new architects, techniques, algorithms, and analytics to manage it and extract value and hidden knowledge from it. As the data is huge, we can get more insights from the data which can benefit the business. And who are generating the big data? See, we get the data from the YouTube, we get the data from the security cameras, we get the data from the thermostats, from the logistics, from the emails, from the social media media networks, from the RFID, from the sensors, from so many automation, from the existing systems from the organization. So all these data can give new insights. So what are the characteristics of the big data? As we already said, as the name itself dictates, volume. It has nearly petabyte or terabytes of data. And variety. Early days we used to have only text files or we used to work on only the text files, and now we have the data or we used to work only on the structured data. Now the technology helps us to work on the unstructured data too. That where the big data, you get the data from the sensor, you get the data from the IoT devices, which can be images or it can be audio, and even multimedia is another way that where you get the data. So we get different varieties of the data and use from this variety of data also, like you can get many insights. And the velocity, what do you mean? The rate at which the data is coming. So the data, you get millions and trillions or yottabytes of data coming in every second. And also the data veracity is another new thing that which is now added, where there is the uncertainty of the data is also there. Like there we have to kind of clean it or refine it and make some certainty out of it and get insights from the big data. In the current industry, big data has got various applications. If you see, and I just didn't want to go over everything. Just you can see in the retail and the consumer segments. It can help you to see the customer segmentation. So where we can focus on the personalized marketing also. And even the event and the behavior-based target marketing you can do. And you can also find it out who are all the customers that are loyal. And we can help us to do the market basket analysis also. In the financial and the fraudulent section, that it helps us to find the risk management, also any fraud activities that happened in the credit card systems too. All these things are possible because of the big data. And the web and the digital media, you can find the digital marketing could be done, and the e-commerce and the customer service, that you can do the recommendation engines, that you see when you're ordering a particular product in their Amazon, you can also see that they would recommend, okay, I mean, similar people like have bought these things also. It is possible due to the recommender system. And the telecommunications, it can help us to do the mobile user location analysis also. And you can also find out overall the churn modeling, which customers will stay with your mobile and who will leave. And in the health and the life sciences, the uses are tremendous. There are lots of diagnosis could be done with a huge amount of data. And we can also preventive care is it's possible because of the big data. Okay, so far we have talked about what is the importance of data and as well as why big data. Now, what is Hadoop? So Hadoop is not a big data and it is not a database. It's a platform which allows the user to quickly write and test distributed system which is efficient in automatically distributing the data and work across machines. So if you see in the diagram that we have in the in the early days we used to work in a local system, and local system you may not do so many things. And now we have the distributed system. And the Hadoop works in the distributed environment. It's a way to distribute very large files across multiple machines. And Hadoop uses a HDFS file system, which is the Hadoop distributed file system. And the communication between the systems in the Hadoop is to the resource manager called the yarn. And Hadoop has also got a fault tolerance where it itself replicates the files to a minimum replication which is there in the Hadoop S3. It replicates the files and keeps the different data nodes where even if any one machine fault happens, it could able to retrieve the data from the other data nodes. And basically it is using a MapReduce. MapReduce helps us to do the computations of the data. So in the Hadoop that you have a name node and you have multiple name node is just kind of like a master node. And it is the one like which is it's also kind of like a dictionary. Just like in the database, you have a master database. Similarly, here in the master or the name node works like a master one. And this is the one which identifies what all the data nodes are there, what work can be given to what data nodes. So this is kind of like a master and it is monitoring the various data nodes. And in the HDFC, in the HDFS, we'll use blocks of data with a size of 128 MB by default. Each of these blocks is replicated 3 times, and you can change the replication also depending in the settings. The blocks are distributed in a way to support fault tolerance. That is, the data is being spread across a data nodes. The replicated data files will not be saved in the same data node because if that particular data node goes wrong, then having the replication in the same data node is not going to help you. So the replicated data will be in the different data nodes. That's right. When if one data node goes off, it can take the file automatically without the user's knowledge. It can take the file from the other data node and the processing will start. What is MapReduce? So MapReduce is a way of splitting the computational task to a distributed set of files. It consists of a job tracker and it consists of a many task trackers also. The job tracker sends the code to run on the task tracker. The task trackers allocate CPU and memory for the task and monitor the task on the worker node, just like a master. And the MapReduce contains a mapper function that passes source code and maps values to the unique case. And the reducer function that processes all of the values for each case. So in the MapReduce, it's kind of it is written on Java, and you have to write a bit more code in the MapReduce. HDFS, as I've already told, it is the distributed file system and it's a primary data storage system used by the Hadoop application. And it contains a name node and it is kind of like a master node as I've already explained, and it contains a metadata which defines like what files are there in what nodes and what file that replication is there in what data nodes. All this information will be available in the name node. And what job needs to be given to the what client also the name node does. And this yarn is nothing but like the resource manager, just like what that actually manages the resources. And sometimes the yarn can be in the name node or it can be in a separate node also. Most of the time it will be there in the name node, and it is the one which finally out what job is running in what data nodes. And if next job is coming and it is the one coming on the way, and this is the one sees and to which data node the job needs to be given to. So this is the entire Hadoop ecosystem, and we have Kafka, Flume, Scoop, and we have the Hadoop HDFS, and we have the Hadoop Yarn, and we have the Hadoop MapReduce, Zookeeper, Storm, Solar, Mahout, Hive, Pig, Graphics, Spark, HBase, and Cassandra. Let us go through one by one, what each system is. We take the Flume. Flume is nothing but a high volume injection of a streaming data. It's just like kind of a log or a channel. Suppose we want to send the file to the Hadoop where the processing starts. The file to the Hadoop or the file to the HDFS can come from the various servers or from the various systems. If all the system trying to send the file to the Hadoop, those Hadoop has got as a distributed, it's a powerful engine. It may the file, when it is all the files getting passed on to the Hadoop, it can get clogged. So Flume is just working like a message brokering service where it has a channel. It sends the file in a sequence and sees whether the Hadoop system is kind of loaded, or it takes care of it to send the file at the predefined time. So we will be seeing about this tool in a few minutes. And Kafka is also very similar to Flume, where it is also used like a real-time message brokering service. Scoop is a tool like where it helps to transfer the data from a RDBMS to the Hadoop or vice versa. It is from Oracle or SQL Server or Postgres or any RDBMS system, like it will be able to transfer the data from the RDBMS to the HDFS system. HDFS, I've already seen, it is the primary data storage system used by the Hadoop applications. And Yarn also we have seen, it is a resource manager. And MapReduce is nothing but a batch query processor and the ability to run an ad hoc query against a whole set of data. That is the basis for the Hadoop, where computation for the data has been done in the MapReduce. And Spark is a custom computing framework for large-scale data processing. It provides a direct acrylic graph engine and APIs to Scala, Java, and Python, or even Scala and R can be used for the Spark. Spark, the highlighted ones we will be seeing in detail. Spark is also a powerful tool where it helps to process the data. Pig is nothing but a data flow engine for exploring a very large data set. Hive is kind of like a warehouse in the HDFS system. Mahout is also a library of a scalable where machine learning algorithms can be run using the Mahout. Solar is a tool for indexing large blocks of unstructured data, so the data processing can be done efficiently. Storm is also from Apache. It's an advanced big data processing engine that processes the real-time streaming data. And we have the HBase. HBase is also scalable distributed, and it's a NoSQL database built on top of the HDFS. Cassandra is also an open source distributed database system that is defined for storing and managing the large amounts of data. Zookeeper is a centralized service for maintaining configuration. It helps to configure all the data, all the tools what we have seen so far. We will also see in the next video some of the basic HDFS commands.